Hello, my name is Simon Foley. I'm from Vishay's IC Market Development Team. Today I'd like to take you through a presentation to show why we need to accelerate the integration of power conversion with Vishay's Microbuck and microBRICK in industrial automation and control applications. In a typical industrial system, the end point of loads are usually those electronic chips that require a stable DC power supply. These chips can be CPUs, SoCs, memories, displays and hard drives. Just to give an example, to power these chips, we need to go through two stages of conversion to deliver the energy from the AC output to the final point of load. So the essential first stage is an AC to DC converter that establishes an intermediate bus like 12 to 48 volts. The second stage converts the DC bus into a more refined, low DC power supply for the end application. Microbuck and microBRICK products are Vishay's latest offering in this market to address essentially the second stage conversion. Both Microbuck and microBRICK are single-phase synchronous buck converters that convert a high DC input to a low DC output with very high current capability. The DC inputs we are talking about here range from 5 volts to 60 volts. The output can be as low as 0.6 volts up to 12 volts. The Microbuck and microBRICK families are capable of delivering up to 40 amps. Let's now look at the 5 power trends and challenges for this market. We see power consumption increasing significantly in the next decade. We need to develop more efficient power solutions. Because of the increase in power consumption, cooling costs and complexity is increasing. Superior thermal performance is required. CPUs and SoCs are becoming more and more power hungry, where we see a requirement for fast load transients. Less space is being allocated to the power converter, where more is being allocated to CPUs, SoCs and the silicon. We need to reduce the size of our packages and increase the power density. Last but not least, we see more stringent and tougher application environments requiring the highest reliability solutions. In answer to these challenges, there's only one answer, and that answer is integration. Let's now look at different levels of power integration. Early century, design is designed discretely. In 2006, Vishay launched its first ever VR power product. We integrate the driver IC and the two MOSFETs into one package. This is the very early stages of power integration for us. This series of product has been very successful and we are now one of the biggest suppliers of this type of product. In 2009, we entered a new era of providing and developing the Microbuck family that offers a complete solution with a controller IC and two MOSFETs into one package. Of course, microBRICK is the new brand addition to the Vishay family. We introduced the very first product of microBRICK 2 years ago in 2018, which really boosted the higher level of integration with the inductor, the MOSFETs and the controller into one package. The key ingredients for power integration comes from multiple dimensions and multiple disciplines. First of all, you have to have a cutting edge that benchmark the best master technologies. As we all know, Vishay has been a market leader in this area for many, many decades. Secondly, innovative IC design expertise would bring a significant value to our products. As we all know, the MOSFETs, they are the muscles and we need the brains to operate these muscles. And the IC design brings significant value into our product. Thirdly, the company who does design a product must possess an advanced multi-chip package technology that can manufacture and support in a reliable and cost-effective way. Number 4, you must have a top-notch quality control system and a strong customer service infrastructure to support global customers and global demands. Last but not least, you must have the business mentality that is nimble and flexible to tailor-make your customized product solutions to fit different customers. All in all, Vishay as a company, we have all these important characteristics and capabilities to answer the call for integration. There are 4 important qualities of Microbuck products for a design engineer or power engineer. First of all and foremost, the most important thing is efficiency. So Microbuck products offer the highest efficiency in the industry thanks to multiple reasons. First of all, we have the latest trench MOSFET technology that offers the benchmark performance in the industry. When we say benchmark performance, we talk about the lowest RDS on and the best switching performance. In this way, you save both conduction losses and switching losses altogether. So high efficiency is the first and the most important criteria of the product. The second is the high switching frequency. If you compare our Microbuck products against a discrete solution or our competition, the benefit of using Microbuck is that it enables you to operate at much higher frequencies. When we say higher frequency, we are talking about 1 megahertz or even higher frequencies. It's twice as fast as discrete solutions and our competition. The third point is about the trend in performance. So if you look at the Microbuck families, all of them employ a very advanced control architecture called constant on time that delivers super fast, low transient boost and saves lots of output capacitors and reduces the overall size. So it enhances the power density of the solution. The last is thermal. Again, thermal is always challenging for the industry. So with Microbuck, advanced packaging technology, with multiple chip solutions, we can deliver the best thermal performance with low temperature. Let's look at the difference in efficiency using Microbuck against a discrete solution. In this instant, we've used an SIC462, which is a 6 amp device, against discrete solution under the same conditions, 5 volt output. In the graph, you'll see 8 curves. 4 of them are in bold, representing the Microbuck SIC462, and 4 in dotted lines, different colors, representing the discrete solution, the different colors representing different input voltages. And at full load at 6 amp, you'll notice a 7% difference improvement in efficiency using Microbuck. This translates to a 50% lower power loss. Looking at Microbuck's thermal performance against competition with the same power capabilities, you'll see the thermal difference based on the thermal camera capture is significantly different. With the same power delivering capabilities, we are 25 degrees cooler than competition, as clearly shown here. That's thanks to the advanced packaging technology and advanced MOSFET technology. It provides faster switching performance to deliver the best thermal performance against our competition. Looking at the Microbuck family, let's look at the Y and X axis. The Y axis is the input voltage and the X axis is the output current capability. As you can see, we offer a wide range of products for input voltage compared to output current. The input voltage can go from 3 volts to 65 volts, 72 volts absolute maximum, and the output current can go from 2 amps all the way to 40 amps. Looking at a solution for 4.5 volt input to 60 volts, we have our SIC46X series. Now this series is aimed at industrial robotics and automation applications. It's in a 5x5 package and with an adjustable output voltage down to 0.8 volts. There are 4 products in one series, 2 amps to 10 amps, and they are scalable, which means they are pin for pin, same package size. We also have our 466 series as well, up to 469, which has internal compensation. The peak efficiency is 98%. The switching frequency is adjustable from 100 kHz to 2 MHz, and it has force continuous mode and power save mode options too if you need light load efficiency. Looking at robustness and reliability, it has cycle by cycle current limit, over voltage protection, short circuit protection, a power good flag, and over temperature protection around 160 degrees. For lower input voltages up to 28 volts, we have our SIC43X series. It's in a 4x4 package and it's a scalable family from 8 amps to 24 amps. It has internal compensation, 1% output accuracy, and a peak efficiency of 97%. The operating current is 50 microamps. The switching frequency can be adjusted from 300 kHz to 1 MHz. For voltages up to 20 volts, we have our SIC4X series. This is a 5x7 package and it's a scalable solution from 15 amps up to 40 amps. It has a PM bus interface, which is based on I2C protocol, but it's for industrial applications. It provides the designer with greater flexibility to finalize and optimize his design, looking at live performance and failure analysis. Let's now look at how a multi-chip module is configured using our microBRICK. On the right hand side you'll see the lead frame. This is the mechanically rugged frame of the package. Onto it will bond wire the IC, the low side and the high side MOSFETs. On top of that we'll add a thick copper clip This connects the high, the low side and the outside world together. Onto it, we'll connect the inductor. Now this also acts as the heatsink. On the far left, you'll see a 3D glance at the package. As you can see, the MOSFETs, the IC and the lead frame sit underneath the inductor and add no extra area than the inductor itself. Let's look at the microBRICK family. There are three flavors: SIC 967, 4.5 volts to 60 volts at 6 amp, SIC 931, 3 volts to 20 volts at 20 amps, and SIC 951, 4.5 volts to 20 volts, 25 amps out, which also has the PM bus interface. The package is 10 by 6 by 3. It's the most power dense solution in the market, which is 50% smaller than competition in area and up to 70% smaller in volume. Let's look at the three flavors of microBRICK in more detail. This is the first, the SIC 967, 4.5 to 60 volt at 6 amp output. The output can be adjusted down to 0.8 volt, the output accuracy is 1%, and the switching frequency can be adjusted from 100 kHz to 2 MHz. Because of the configuration of microBRICK, we can see a 98% peak efficiency at 1.5 MHz. The second is the SIC 931, 4.5 volts to 24 volts at 20 amp out. Now this can be adjusted from 600 kHz up to 2 MHz, and the peak efficiency we see at 1.5 MHz is 95%. The third microBRICK is the SIC 951. This has an input voltage from 4.5 to 20 volts and an output current of 25 amps. The output voltage can be adjusted down to 0.3 volts. The output accuracy is 1%. Switching frequency can be adjusted from 600 kHz to 2 MHz. And because of the configuration as the previous ones, we get a high peak efficiency, 98% at 1.5 MHz. The third microBRICK in the series is the SIC 951, 4.5 to 20 volt input, 25 amp output. This has the PM bus interface. The output can be adjusted down to 0.3 volts with 1% accuracy. The peak efficiency is 98% at 1.5 MHz, and the switching frequency can be adjusted from 600 kHz to 2 MHz. This is also in a 10 by 6 by 3 package. To support microBUCK and microBRICK, we have evaluation boards and evaluation board manuals. You can find this from the document library from our website. You can also check evaluation board stock. We've just launched our new power card. It's a new online design tool that allows engineers to customize, analyze and finalize their design. You can get there from the link you see on the screen or from any Vishay Microbuck microBRICK datasheet. When using PowerCAD, you'll get a product selection guide. Depending on your filtering and your conversion specification, you'll get a list of part numbers you can choose from. Then you'll get a schematic and a bill of materials. The peripheral component values are calculated by PowerCAD, and it saves the engineer calculating from the formula in the datasheet. You'll also get the efficiency and the thermal analysis from the conversion specification. There's an online simpler simulation where you can look at load and line transients and look at output, input, IC, switching characteristics, for example.